Here we have a SAT math problem. Okay, let's go to the question. The XY plane shows the graphs of a linear function and a quadratic function where A is a constant. If R, S is a point of intersection, what is the value for R? Okay, here we have a line which is given by the linear function and a parabola which is given by the quadratic function. Both the line and the quadratic function intersect at 2 points. One is the origin over here 0, 0, and the other point of intersection is R, S, that is given in the question itself. In the second point of intersection R, S, we have to find the value of R, which is a x coordinate. Okay, now to get the point of intersection, the x coordinate and y coordinate, the point of intersection, what we have is we have to solve the given system of linear equation and quadratic equation. So for that we need the equation of the line, that is the linear equation, and the quadratic equation is given, but in this quadratic equation it's incomplete because there is an unknown constant a over here. Only if I know the value of this unknown constant a, this equation will be complete, this quadratic. So once I know the equations for both the line and quadratic, so I'll be able to solve them and get the point of intersection, particularly the x coordinate over here. Okay, first let me get the linear equation that is given by this line. So for that, what we can do is we can consider the point we have over here. At this point, the x coordinate is 4, y coordinate is also 4. So that is, we have x coordinate 4 over here and y coordinate 4 over here. So that is, we can take this one as rise. Rise is 4 units the length over here. And also we can take this rise as positive because it's a rising line. And run over here, it's an horizontal distance, that's also 4. Then the slope of the line m equals to, the formula is rise over run, and rise is a positive value, that is 4, and run is also 4. Then I'm getting m equals to 1. Okay, now I got the slope of the line. Then we can write the equation of the line in slope intercept form, that is y equals to mx positive b, and we can plug in this 1 for m over here. Then I'm getting 1 times x positive. So this b is the y coordinate of the y-intercept. We know that the line intersects the y-axis at the origin 0, 0. So this is the y-intercept. This y-intercept, the y coordinate is 0. So we can plug in 0 for b over here. Then I'm getting y equals to x. Okay, now I got the equation of the line, that is y equals to x. Okay, already we have the equation of the parabola, it's over here, but I said it's incomplete because there is an unknown constant a over here. Okay, now let's find the value of this unknown constant a. Let me write the given quadratic equation, that is y equals to a times x negative 4, the whole square, positive 8. Okay, now to get the value of this a, what we have to do is we have to plug in one of the points of the parabola into this equation. So we can consider the point, the origin 0, 0. So because we have this point and the parabola, so we can plug in this point 0, 0 into this equation. That is, we have to plug in the x coordinate 0 for x and y coordinate 0 for y over here in this equation. Okay, let me do it. So 0 equals to a times 0 negative 4 the whole square, positive 8. Then I'm getting 0 equals to a times 0 negative 4 the whole square is just negative 4 the whole square, positive 8. Then I'm getting 0 equals to the value of negative 4 the whole square is just 16. 16 times a is 16, a positive 8. Okay, now let me subtract 8 from both sides and I'm getting negative 8 equals to 16a. Let me divide both sides by 16. Then this 16 will cancel out, and 8 goes into 8 one time, 8 goes into 16 two times, and I'm getting negative 1 over 2 equals to a. Okay, now I got the value of a. Now in the given quadratic function, we can plug in the value of a over here. Then we get y equals to negative 1 over 2 times x negative 4 the whole square, positive 8. Okay, now I got the linear function. That's for the straight line, that is y equals to x. And here we have the quadratic function, that's for the parabola. Okay, now what we have to do is we have to solve the system which contains this equation and this equation, and find the value of x, which gives the x coordinate of the point of intersection. So in this case, we have 2 points of intersection, 0, 0 and r, s. So here in the first point of intersection, the x coordinate is 0, but in the second point of intersection, the x coordinate is r. So that's what we have to find. Anyways, now we have to solve the system which contains these two equations. Okay, let me erase the other stuff and continue the problem. Here we have the system of the linear equation and quadratic equation, and we have to solve for x in this system, which represents the x coordinate at the point of intersection. Okay, now what we have to do is, so to solve the given system, we can plug in this x for y over here, because in the first equation we have y equals to x. So since y equals 6, we can plug in this x for y over here. Then I'm getting x equals to negative 1 over 2 times x negative 4 the whole square, positive 8. Okay, let me subtract 8 from both sides. When I do so, this positive 8, negative 8 will cancel out. then I'm getting x negative 8 equals to negative 1 over 2 times x negative 4 the whole square. Okay, now let me multiply both sides of this equation by 2 to get the denominator 2 over here. Let me multiply the stuff on the left side by 2 and the right side also by 2 over here. Then we get 2x and negative 16 when you distribute this 2 to this x and 8, and here this 2 will cancel. Then I'm getting negative 1 times x negative 4 the whole square. Then I'm getting 2x negative 16 equals to negative 1 times, okay, we can expand the square of the binomial over here using the algebraic identity, that is a negative b the whole square equals to a square negative 2ab positive b square. Comparing this and this, we get x at the place of a and 4 at the place of b. So to get the expansion for this one, we just have to use a trinomial. In this trinomial, we have to plug in x for a and 4 for b. Then I'm getting x square negative 2 times x times 4 positive 4 square. Then we get 2x negative 16 equals to negative 1 times x square negative. So when we simplify this one, I'm getting 8x positive. The value of 4 square is 16. Okay, now we get 2x negative 16 equals to, we can distribute this negative 1 to this, this and this. Then I'm getting negative x square, negative times 90 will become positive 8x. Negative 1 times positive 16 will be negative 16. Okay, now what we can do is we can add 16 to both sides to get this negative 16 on both sides. And also let me subtract 8x from both sides. And also let me add x square to both sides. Okay, so to get the quadratic equation in standard form, so when I do so, this negative 16 positive 16 I will cancel. The same here, negative x square positive x square will cancel, positive 8x negative x 8x will cancel out. So on the left side now we have x square and 2x positive 2x negative 8x. When I combine them, I am getting negative 6x equals to, on the right side we have nothing because everything is cancelled. We just get 0. Okay, now we can factor and solve this quadratic equation. So here on the left side for these two terms, the greatest common divisor is x, so we can factor x out. When I factor x out, then I'm getting x times x negative 6 equals to 0. So here the product of these two quantities equals to 0. So whenever the product of two quantities equals to 0, either the first one has to be 0 or the second one has to be 0. So if the first one is 0, we get x equals to 0. If the second one equals to 0, we get x negative 6 equals to 0. So to solve for x in this one, we have to add 6 to both sides. Then I'm getting x equals to positive 6. Okay, now I got two values of x. So these two values of x represent the x coordinates at the point of intersection. So because the parabola and the line intersects at 2 points, one is at the origin and the other one is at the point r, s. So clearly the first value of x0 over here, so this is a x coordinate at the point of intersection at the origin, so 0 over here. So and the second value of x6 is the x coordinate at the second point, that's over here r, s. So here the second point of intersection, the x coordinate is r, but here we got x equals to 6. Therefore the x coordinate r over here must be 6. So this value of r is 6. We find this 6 in answer choice A. The correct answer choice for this question is A.